Let a and b be positive integers such that a plus b is equal to 20. What is the maximum value that a squared b can take? Okay, my first instinct here is to take this expression a squared b and write it in terms of only one of the variables, a and b, because we'll be able to substitute for one of them as, a is equal to 20 minus b, or vice versa. So we can write a squared b in terms of only one of the variables, and then just do a standard maximization. So let's start with that. We have a plus b is equal to 20. And keep in mind that a and b are both positive integers. So we want to maximize a squared b, which is equal to, let's write everything in terms of a. So this is equal to a squared times 20 minus a, which is equal to 20 a squared minus a cubed. So I want to maximize this. What I think I might do now is treat this as a real variable. Well, we could probably just do this by inspection. If I do this by inspection, this is clearly going to be increasing for small values of a, but then eventually this one will dominate and it'll be decreasing. So we just need to find out when this the direction of increasing versus decreasing changes. Maybe let's treat this then as a function of a single variable, just so we can have a guess or an approximate value of a for when the derivative changes sign. So 40a minus 3a squared. I want to solve for when this is equal to 0. I don't want a to be equal to 0, so we have 40 minus 3a is equal to 0. So a is equal to 40 over 3, which is somewhere between 13 and 14. So the value of a for which this turns around is between 13 and 14. So that means this is increasing for values of a up to 13 and then decreasing. So what I think I'll do now is this doesn't tell us exactly whether it's at 13 or 14. That gives us the minimum or maximum. So I might just evaluate this function. I might just evaluate this at both 13 and 14. Is that going to be too much mental effort? Okay, well, let's go back to the original expression, a squared times 20 minus a. For a equal 13, I have a squared times 20 minus a. So 13 squared times 7, which is, what is 13 squared? 169 times 7. So I get 1143. Now let's try it with a is equal to 14. 14 squared times 6, that's 196 times 6. and I get 1176. So 1176 is option C, and this happens when A is equal to 14. Yeah, you have to be a little bit careful on this one, recognizing that when we solve for, when we know that the turnaround here for A is between 13 and 14, A is not going to be an integer, and so you really have to test both endpoints of that interval to figure out on which side the value of the value is bigger. Maybe there's another way of doing this without sort of treating A and B as real variables and then just taking the closest integers as being, taking these real numbers as candidates for the closest integers like this. Maybe there's a clever way of doing this using only integers everywhere. But I just didn't see it right away. And my instinct was, let's just treat this as like a real valued function of a real variable and then check the close by integers. Yeah. If I have a mistake or if I have more to say, I'll write it down in the description. Thanks for watching.